DNA replication. DNA replication is the process in which new DNA strands are made by copying and complementing an old DNA strand. There are two main steps in DNA replication, initiation and elongation, which are both composed of smaller and equally as important steps. Step 1. Initiation. The first step to DNA replication is to separate the two DNA strands in the double helix. This is the job of the enzyme helicase, which breaks apart the bases that attach the two strands. Then, to assure that the strands don't reattach, single-stranded binding proteins, or SSB proteins, bind to the strands. Step 2. Elongation. Starting at the 3' end, since the nucleotides have to be added to the hydroxyl which is found at the 3' end, the enzyme primase creates RNA primer on each end, which will tell the DNA polymerase III where to start working. DNA polymerase III will know to start at the RNA primer and will begin to replicate a new DNA strand from an already existing one. There are two kinds of strands, the leading strand and the lagging strand. The leading strand starts at the 3' end and is synthesized from the replication fork, whereas the lagging strand is also starts at the 3' end but is synthesized away from the replication fork. With where the 3' end is on the lagging strand and where the DNA polymerase III begins creating the new DNA strand, it creates small sections called Okazaki fragments, as it has to continuously go back to the beginning where more space has been made by the helicase. This means that the primase has to repeatedly make new RNA primer for the DNA polymerase III to begin the new strand. These sections are joined together by DNA ligase. Both processes will be shown in the next videos. The final product of DNA replication is two new DNA strands that will pair with one of the old DNA strands to create a double helix DNA strand. Thank you for watching, and I hope you now understand what DNA replication is and how it works.